Thank you. So it's after lunch. Everyone's going to be excited. So I thought I'd speak in an exciting tone. Anyone seen Ferris Bueller, Stale? Yeah. Yeah, that guy who was the economist went to school with, high school with one of my colleagues at GW, and used to tell us all about what he, Ben Stein, is like. So he's still a nice guy, and he's a smart economist. His father, of course, was a very famous economist. So to get up there and actually make fun of economists must have really chagrined his dad at that point. Anyway, so let's get moving. Review. I'm going to go over something you've seen. This will bore you, okay, because you've seen it before. All right, so multidimensional poverty, about more than money. If it's about more than money, you better faithfully represent poverty with other things besides money. It's only ethical. But is it really making any difference? That's a question. And we answer yes, yes, yes. We have a fine quote here from Amartya about the way that people's lives are beat up in lots of different ways. Question is, what framework might be useful for encapsulating this new way of thinking about poverty, incorporating all these dimensions? And one of them is, and I think the one that we've all used quite often, is the capability approach of Sen. It's made up of functionings, capabilities. How do the two differ? Do you remember? Which one would be a point? Which one would be a set? Anyone remember? Set, capability set. It's like a menu of options, whereas a functioning is an achievement level or what you could be choosing from that set. And this has really had a big impact on folks. So you really want to get a better approximation of what's happening in the lives of people. As I said, it's only ethical. But again, maybe monetary poverty is enough. You know, I've been working on a document the World Bank is going to put out, and so has Mr. Kim here, which is going to talk about different ways of measuring poverty. And so they're including depth and breadth in the discussion, breadth being represented by the approach you're learning here. And it's really interesting to talk to people who are used to thinking about poverty only as a monetary idea. And it's really refreshing to meet people at those institutions who have a broad vision of what poverty ought to be. So it's been a great experience. So maybe empirically everything just goes together. The answer is that this empirical question, you can't just sort of put it down as an article of faith. The question is empirical question. What about the evidence? You can't just take it as faith, so what are you going to do? You're going to look in the evidence. We find all kinds of mismatches. I was just looking at table 1.2 in the book. All kinds of the correlation in some sense between pairs is just not that strong. Okay, you could be deprived in one. It doesn't mean with any good probability you're going to be deprived in another one of the other dimensions, say in the MPI. So you have a lack of association between levels and between reduction. And this is what that graph pointed out when you went through it yesterday. It also is present in MDG targets. You know, you have some that were met and others that were far from being met. And so if you have a lot that are far from being met, there are a lot of people walking around that are in the one group where it was met, headcount, poverty, monetary, and yet not having a lot of other ones met. So this is part of a larger problem, really. It's a lack of inclusiveness of economic growth. If growth could do everything, you'd be fine. So it doesn't happen, though. And I believe that you've seen some great evidence given by Sen and Dres on this. And I won't go through it again, but you can see that up on top you have India growing at this nice clip, even more so now, but yet lagging behind the neighborhood in terms of other important dimensions. So that gives a good justification for expanding beyond monetary dimensions. How should we do this? Well, one could just list what we just saw a second ago with the MDGs, the kind of dimension by dimension how a country seems to be doing. But there are two problems with that. A minister asks you, who's poor? What do you say? There's no identification as to who is poor. It's just an identification of who's deprived in one thing, deprived in another, deprived in another, deprived in another. The second is that you have no overall figure to capture the attention and motivate people, a headline figure. So there are a couple of things that cause you to think maybe dashboard isn't quite enough. Should we in fact focus on what poverty really means in terms of these underlying dimensions, give a coherent definition, and then provide an indicator which itself may have associated with it other dashboards of interest, but which has at the top a figure you can watch over time and over space. Okay, is it enough to look at deprivation separately? MDG, no. The problem is you can have the same marginal distribution, separate dimension, and have very different joint distributions. Remember this one? Okay, so the poor guy that's deprived in everything in the right-hand side is really out of luck, whereas the other people may not be. In fact, it could just be a data problem. You're deprived because you were cut over the deprivation cutoff a little bit, and there might be mistakes like that occurring. And we can see it also in the distribution of, if you will, numbers of deprivations in Brazil. So I would contend, and many others would too, that how you measure something influences what policies you use for it. And if you look at monetary measures, they often are accompanied by a call to grow and to transfer funds. Transfer is the least sustainable. Growth is a magic box in many cases. It takes a long time. There are things you can do right now in other dimensions that can have a huge impact on future growth and make sustainable growth. So it's better to go back and pull into these other dimensions, to think about comprehensive policies that affect many dimensions simultaneously, to perhaps even coordinate your development plan in terms of these many dimensions through a coherent poverty measure, and also to communicate with everybody that way. Actually, coordination is a kind of communication across the group of leaders, if you will, the people running the show. But communication can be more broadly to all stakeholders who are interested in the poor. So while a good poverty measure alone can't create good policy, it can be a start. It can be designed to facilitate that. And this table of so-called desiderata are linked to, related to, tables that we've been describing for quite a while. But here we're actually talking about various aims that you might use a poverty measure for, and that a good poverty measure may contain several of these aims at once. It could be used for the official statistic in a country. It could be used to identify what kinds of patterns of poverty are occurring and deprivation within that poverty. It can be used across different regional, subnational, ethnic groups of salience. It can report poverty trends over time, monitor changes in each indicator as the overall indicator is moving, evaluate the impact of development programs on poverty. Can you imagine? On poverty and multiple outcomes at once, so that you could explain, hey, this program I'm doing is going to have this impact on poverty through this channel. And it can target geographical regions or households for particular purposes, which is related to the discussion above. So, what methodology? Well, you got it, I'm sorry. If you've come here to listen to other methodologies today, you're just not going to see them. I hope, did you get a chance to meet my good friend and the person who's referred most to my work in my lifetime on yesterday, Martin Rebellion? Yeah, so he will have a different methodology than this. But thanks to you and thanks to others like you, people seem to be interested in this methodology. So I will continue despite any errant remarks by people who might be nearby in their office, but all right. No, I met Martin when he was a young man in 1988, I think. Very nice guy. I've been out for many years. I had already 10 years before published a paper by that time. He was kind of a new guy. But he really helped me out a lot by writing a lot of stuff in my work. So I have to say, hats off to you, Martin. And he actually is one of the real top thinkers on the idea of poverty. He's, spent a heck of a lot of time thinking about it in a particular way, but yet thinking about it very deeply, and has added to the discussion in ways that none of us, I think, can actually come close, because during the last 30 years, he's helped forge an agenda that has been very powerful. Okay, multidimensional data. What did data look like? Here you are. You like matrices? Who likes matrices? I like matrices. Who likes eigenvectors? You like eigenvectors? Yeah. How about eigenvalues? Anyone like eigenvalues? Determinants? Yes. Determinants? Oh, okay, great. So I have someone out there. The rest of you are like, I'm not going to talk about any of those things today. Okay? All I'm doing is capturing the data in this form because it's easiest. And anyway, data come like this. I mean, they have other columns or rows, right? But the substance is right here. So let me give you an example of what this could be. It could be that the first column is income in dollars per day, following Martin's lead. Okay, in this case, maybe we're talking about an example from a developed country rather than a developing country, because all the people here have pretty reasonably high income levels in dollars per day as compared to a lot of other places. Okay, so this person has 13.1, 12.5, etc. Then, here's a dimension. I wonder what that, how about schooling in numbers of years? Now, I'm not going to call that education, because actually education is different than schooling. Education has lots and lots of dimensions within it, which makes it hard to measure itself. But schooling is easy to measure. But don't call it education, otherwise Jerry Behrman and lots of other people will be upset. So I do it myself all the time, and so has he. So in this case, we have someone with 14 years of education, high school, 2 years of college, 7, 10, and 11. All right, understandable? Now, here's an interesting column. It has self-reported health, something I started working on at the, implied by our friend Angus Deaton, who worked with this stuff, and he did it in a kind of different way. He thought those numbers would actually have cardinal meaning. But these self-reported health numbers are corresponding to categories. Do you think your health is excellent? Very good, good, fair, or poor? Put these numbers to them. You can't treat those numbers as if they are cardinal indicators. That leads to this notion of ordinality for measures that don't change when you change which particular numbers you've thrown in there. Okay? And so that's a property that we are very serious about in our discussion. Okay, and then finally, so this is someone with poor health, this is someone with excellent health, and all the gradations in between. Finally, 0, 1 refers to whether you have access to a public service, let's say, or maybe insurance, or not. So, who is deprived? We figure out who's deprived by looking at these deprivation cutoffs. They're usually associated with something called Z. 13 is the number of dollars per day. That make it so that you have a minimum level. Below that, you're deprived. So, who's deprived? You can calculate for yourself. High school education. Fair? No? This is good. Okay? So below good, which is fair and poor, are the two categories of deprivation. And then I see 1 here. You say, what do you mean 1? What 1? Below 1 means you're deprived. So I could have made it a half or something else, but I put it as 1, which is at least one state that you could see. So who is deprived? Well, these entries fall below the cutoffs, and hence those people, here are persons, are deprived in those dimensions. Okay? So that's the idea here, is that we first observe the deprivations. Let's then do a shorthand for this called a deprivation matrix. God bless you. It has zeros if not deprived, 1 if deprived. It's called G0. Now, if we have weights, which very often is the case, in fact, always we have weights, it's just that they could be equal, then it's important, it becomes important to kind of redistribute. In this case, I have 4 dimensions, so I'm counting each of them the same implicitly if you look at the first picture. But if I want to change that, I'll take those 4 and reallocate them across the different dimensions, okay? When I do that, I have weights. These weights, W1 through W4, could be, let's say, 1.5 for someone who really thinks income is important. 0.5, someone who thinks this. Yeah, I know. 1 and 1, okay? That would be an example. So when it comes to figuring out not the deprivation matrix, but the weighted deprivation matrix, just put those weights right in the matrix. Replace the ones with them. So you can remind yourself how much each time you're deprived, how bad that is, okay? Now we identify by counting dimensions. Yes, question?
The weights are actually for the dimensions. I can see W1, column 1, W2, column 2.
Yeah, precisely.
Column 1.
Column 1. Because I wouldn't want to weight different people differently. That seems a little unethical, but some people do that. Okay, we're not doing that here. We're going to focus on dimensions and think, well, this dimension has greater salience, more importance, policy, impact, etc. This is where I'm going to put my eggs. And these, not so much. Okay? Yeah?
It's like sampling weight. I mean, theoretical weight.
It's different than a sampling weight because sampling weight is given by statistical discussions. These are usually given by reflection and normative discussions, political interactions, often on a poverty committee in a country. Now, if you have global measures, you can't have poverty committees for just one country, so it becomes more difficult and more abstract to do this, but you can still do it as a matter of putting them down and moving on so that you can see what's really happening and see whether the approach actually has delivers on being useful for what you want. Okay. So here's the example. Now, let's go back and assume for the moment equal weights. That would be 1, 1, 1, 1, right? So this is identical to the deprivation matrix, but it's the weighted deprivation matrix for this special case where I assume equality. Note that in the way I'm doing it here, all the weights sum up to D. You could also have them all summing up to 1, where D has been thrown in a denominator to make all of those go back down to sum to 1. There are 2 approaches given in the book. So who's poor? Okay, I have a person who is deprived in nothing with 0 score, if you will. 2, 4, all of them deprived, and deprived in 1, in this case, education or schooling. Okay? So you can see this, and the question is, who is poor? So I have one approach. How about this? And this is what was commonly done in many places. You're poor if you're deprived in any single dimension. I don't care if it's education, income, access to services. You're deprived, then you are considered to be poor. So it's as if you look over here, and if you have a 0, okay, you're not poor. But the rest, poor. Good idea, huh? It's called the union approach. Well, not really, because it leads to, first of all, a very practical matter, it leads to huge numbers. Sometimes 90%, as we'll see in a second. So it doesn't pass the smell test a lot of times. Because what's the whole idea of poverty measurement? It isn't to include everyone and say, yeah, we're all poor. Right? It's to prioritize. Right? It's for governments to look ahead and forward and try and do something for some people who are in need, not everyone. Okay, I have another approach. That didn't work out. So let's take the intersection approach. Instead of smiley face, it's a frown, right? Okay. All right, I tried. You are deprived in all 4, then you are considered to be poor, but none of these characters. So the cutoff is your score has to be equal to all 4. Anything less, no, you're not poor. This is called the intersection approach, and it's also a demanding requirement, right? It's demanding in a different way. Oh, first customer walking out. Always happens to me. I've got to start learning how to lecture. All right, so it's really demanding. Suppose that just because of a fluke of nature, you report that you have enough for this one dimension. I mean, in everything else you're deprived, and it seems like there could be some argument that, maybe this is a little less robust than I would like. On top of it, the practical reason again, it often finds a very narrow slice of people. Very narrow, because who the heck is deprived of everything in a data set? Well, it depends. If you have 2 criteria, maybe they will be. But if you have many criteria, maybe they won't be. Okay, so by the way, Atkinson was the one who used union and intersection. So here's an example just to clue you in that, yeah, this is how it works. This is from an MPI exercise, a kind of MPI exercise, I believe, right, Suman? Oh, he's not here. Oh, this is the exercise that you did yeah, a kind of good MPI that works with the data that is in India. Okay. Try a union approach. Oops. Try an intersection approach. Oops. So, would you agree that we need something in between? Yeah, an intermediate approach would be helpful to make sense and prioritize people who are multiply deprived enough. Focus on those people who are really deprived, okay? That's what we're going to ask. So, how do we do that? Well, what do you do if you're trying to find who's poor? You set a poverty line. Does that poverty line have great salience? It can. People spend a lot of time trying to connect poverty lines to an underlying meaning. But $1.25 a day? Okay. I can give you reasons why it might make sense. I can also give you great reasons why some other number would make a lot of sense too. There is arbitrariness, inherent arbitrariness with cutoffs. I'm going to perform that arbitrariness again. Let's suppose that k equals 2. Okay? That's going to be our temporary criterion for this example, to say, here is what determines whether you're poor, and there are 2 of them here. These 2. All right. But if I have only these 2 being poor, why am I having this deprivation being considered? You usually don't consider data on the non-poor when you're trying to measure poverty. You try and not consider it. That's the focus axiom, and we have a kind of focus axiom here also. So here we go. I'm going to censor out that person. Goodbye. See, that deprivation went away. There it is again, and there it is going away. Notice I put above k, which means the censored deprivation, in this case, weighted deprivation matrix. Okay? All right. So the score for that person now is 0, reflecting that they're not poor. It's the censored score, not the original one, but the censored score. All right. So how do you measure poverty in this case? I have one approach. Why don't we just see what percentage of the population is poor? That's the headcount ratio, both in monetary and in multidimensional poverty. So here we have 2, the middle 2 out of 4. 1/2 is the headcount ratio. Cool, that makes sense maybe. Let's take a look at person 2. I'm going to be a really nasty guy. I think I'm going to make person 2 worse off. See what I did? There you were. You weren't deprived in income. Now you are. Ha ha. All right. Now, I'm sorry, but I think that would probably have an impact on poverty. Okay? This poor person you've just seen become deprived in an additional dimension. Okay, so let's recalculate everything. Yeah, go ahead.
I'm sorry, it was already asked before during one of the previous lectures.
Yes, please.
What about the depth of the...
If you can measure depth, I have a way of including it. The problem is that, like with this dimension here, many categories are ordinal or categorical, which means the depth is something that could be all the way to the bottom or all the way vanishing to 0. And if that's the case, if you can't put some metric in the ordinal space, by definition you can't, then you're stuck saying, I'm sorry, I'm going to give up on this. Now what you can do is like I've done in monetary poverty measurement, and taken one cutoff and then looked at a deeper cutoff and see how the numbers change. That's all very legal, and in fact my student Krisanti Hatsumazura has just finished her thesis in which she describes that approach. Okay? And it's been done here also, but she's done it in actually a very rigorous way where you consider all possible cutoffs and average up all the head counts. averaging the head counts, it turns out, gives you a kind of gap. It's quite nice. Some very interesting work there. Whether it's valid or not, I'm not entirely sure even yet. You know, I'm a PhD advisor. Sometimes I'm not entirely sure if what's written is correct. But, you know, you try and allow creativity to flow. And if others find it interesting, maybe I will too. All right. So the number of deprivations went up. Flip. What happened to headcount poverty? Headcount ratio poverty? Same, right. Okay. So no change. It violates what's called dimensional monotonicity. Oops. So that's a problem. Dimensional monotonicity says that if you are poor and you become more deprived in the sense of having greater breadth and additional dimension, then poverty for you and for the entire population should rise. So let's go back to the original censored weighted deprivation matrix with 0 there. You have 2 and 4. How might we augment information that's contained in incidence of poverty, that's contained in the poverty rate, that's contained in the head count ratio? All three are the same, right? How do we augment that information? Perhaps we could look, we're a multidimensional world, breadth. And that's what this measure does. We look at the deprivation shares among the poor. Here it's 2 out of 4 and 4 out of 4. That average might indicate something. So let's take the average deprivation share among the poor. It's 3/4. And now comes the sleight of hand. Let's just multiply the two together, H times A, and we get the so-called adjusted headcount ratio, which is our measure of poverty used in many, many, many applications and implementations, including the MPI. So, calculating it out, here's H, here's A, multiply those two, and we get 0.375. Cool. Now, actually that's not the only way to measure, to actually come to the numbers, 0.375. Do me a favor. Look inside this matrix. You notice you got a bunch of ones. How many? 6. Okay. If the world were absolutely horrible and everyone was fully deprived, what would that number be? What's the share? 6 out of 16. Yeah. Cool, huh? So, it so happens that if you take the mean of this matrix, you add up all the entries and divide by the numbers of those things, you get the M0 adjusted headcount ratio. And as everyone knows, means of things are really cool to use in statistics because they have all these great properties, you can fiddle around, right? So this is really helpful. Does everyone get it? Okay. Any questions up to now? That means I'm thirsty. All right, let's keep going. So what happens when the number of deprivations rise for person 2? Yeah. Yes?
So if you can tell us about
Oh, okay, yes.
the nature of the variance, like actually shows usually if it's like nominal, ordinal, and the ratios put all this
Yeah.
ordinal number. And sometimes you may have actually on the dimensions both of them.
Both of them, and it becomes a problem.
Okay.
We use the least common denominator in the way that we've tended to apply things, but yes, income might be measured cardinally and beautifully, ratio, right? So, but yet, combining
Yeah, that's
is the problem. So this is an open area. If you have an intuitive way of proceeding, I'm in favor of you doing it. If you can give good justification, Mexico would love to see that. I mean, there's lots of people who are interested in that question. What we have done is taken a kind of theoretical conservative approach. If we can't measure them all cardinally, and also, if we can't measure them all cardinally, then we're going to hold back from using our higher level measures, M1 and M2, which include depth and severity in each deprivation, just like the FTT. Okay. Other questions? Okay. So, number of deprivations goes up here, 3/4. Take the average, it goes up. Hence, M0 goes up. Likewise, just take the mean of this baby and you can see it immediately. So it satisfies dimensional monotonicity. All right. So let's give a bit of a summary of what it's all about. The methodology conveys information on deprivations, correct? Right? It is valid for ordinal data. Yes, it is. Why is that? Because if I had changed those numbers and allowed the cutoff to change accordingly, the deprivation cutoff, you change by a monotonic transformation, which means you just change the scale that you're measuring those things in. The deprivation and weighted deprivation matrices are the same. So it's independent of that scale. We call that ordinality, a requirement for measures. Also, who is poor does not change. That's part of ordinality. Those two things, identification's the same, and the numerical value is the same. It's a strong requirement, but it's what we have conservatively required. Okay, so it's also pretty darn easy to compute. Do you all agree? You'll find out later, but yes, it is easy to compute. You'll be computing numbers of them yourself. And it satisfies really useful properties. The FGT was built, and in fact the name of the paper is, decomposability, a decomposable class, right? Yeah, subgroup decomposition or decomposability is a property that monetary measures satisfy and multidimensional measures satisfy. All it says is that you can cut this room in half and look at these folks, your level of poverty calculated with the matrix and everything over here. Calculate your matrix and everything over here. And then at the end of the day, I look at the percentage of people over here, percentage over here, average those two together, and you get the overall M0 back. That's a cool link. It coordinates the numbers you get for each subgroup through that formula. So I call it kind of a coordinated linking. If you look at those two numbers as part of a dashboard of those that live in the north and those that live in the south, it's a way of coordinating those numbers into an overall figure. We'll have a second form, and the more important form of coordinated dashboard in just a second. That will be through the dimensional breakdown. And here it isn't people, right, that are cut into groups, but it's dimensions that are cut. In fact, we cut them into singleton groups typically, although it can be done by groups of indicators. But typically by dimension, which means that we can see how each dimension is doing among the poor and aggregate back up to see overall what the level M0 is linking to those dimensional values. And I'll show you that in a second. So these are the two really crucial, I guess three really crucial properties of the measures, of the approach, would be the ordinality that allows it to be applied at all in many data sets, subgroup decomposition, which is something which we've known has transformed what's happened in poverty measurement at the bank and many other places, allowing you to produce all sorts of profiles of poverty, etc. And then the new thing, dimensional breakdown. It allows you to see how individual dimensions are linking up with overall poverty and how overall poverty is breaking down into individual dimensions. Okay? All right. And if you can do your cardinal thing, we can go to M1 and M2. It's expandable. It's the best thing on earth to have measures that apply in that case, because then you can turn it over to the person in the audience and say, please give me cardinal indicators. I have something for you. Okay? Okay. Now, let's see how those two properties help. I'm going to have a long discussion of that, okay? I've given you kind of an overview. You may have seen some things yesterday. Have you seen some things yesterday with the MPI? Okay. No? Yes? People are... It doesn't matter. Decomposition and breakdown. This is chapter 5 in the book. Population subgroups. Subgroups. When we talk about population subgroups, we can't kind of say, okay, you're in the middle, so you're going to be in that group, and also you're in that group. It has to be exhaustive, mutually, we know that we don't have anyone who's in both, but everyone is in one, at least. And this is true, all the discussions I'm doing for two groups is the same for multiple groups. the same property applies. We can start and define it in terms of two groups, because we can then apply each to each subgroup, break it down, and you know, decompose, and then decompose within. So you can get any decomposition you want among any number of subgroups very easily by just repeatedly applying this two requirement. So let's set it up. Population size of the matrix is n. N. Matrix X is what we had on the board before, the basic data matrix. It's going to be divided into two subgroups of people. Here it is. Subgroup 1, subgroup 2, or maybe the other way around. But here's two groups of people. Group 1 has population size n1. Group 2 has population size n2. It's just notation. It takes a little bit of notation even to define this properly. Note, yes, n1 plus n2 equals n because of wah, wah. Okay. So here's the situation. The matrix of income, education, oops, okay, I'll call it education for the heck of it. It's related to it. And health. Okay? So there we are, basic data. Notice I say population subgroup decomposability. I have population kind of vague. It's sort of redundant, but we say that to make absolute clarity as to what's going on. Subgroup is also kind of vague because decomposability typically is for population subgroups. But we then turn around and say a poverty measure is decomposable. Yeah, that's the shorthand. If the following occurs, that overall poverty is equal to a weighted average of subgroup poverty levels independently evaluated. Okay, where that same measure is being used on different size groups, as all measures can be used on different size groups. If it can't, then what the heck is the use of a measure? Oh, I can only use for 329 million people exactly. No, it has to be able to be used across different population sizes, and there are properties called replication invariance to do just that. So here we have P of X overall, P applied to the submatrix, and P applied to the other submatrix, the share of the population in that subgroup, the share of the population in that subgroup. Bingo, that's the formula. God bless you. Now, once you have this formula, all sorts of things can be done. In particular, notice, what if there's a big demographic change? But these things don't change all that much. But demographic change. Cool. So this weighting is going to change overall poverty, just purely through demographics. The second half of this report that's coming out, the global monitoring report, will be all on demographic. And it all has to do with these sorts of changes here, rather than focusing on these changes here, although they're important as well. All right. Also, you can kind of state, well, look, this subgroup is contributing so much to overall poverty. And the way you can do it is by using this formula. You take px1 over px and multiply it by the share. So it's really taking this and putting it under each of this, dividing also by here to get 1. So the total contribution is 1, and here's the share and the share of the total. So contribution is a kind of share thing, the percentage contribution to overall poverty. Can someone give an intuition as to what this might mean? Could it be, if it were a headcount ratio, let's say, which has this property, and you had, well, I'll tell you what it means. You don't need to think through it. It means it's sort of like throwing all the poor people into a pot and seeing where the percentage of are in this subgroup or that subgroup. So you're netting out all the population share stuff just to look at contribution to overall poverty. Is that right, Suman? I hope so. Many years ago, Suman was a beginning student at Vanderbilt University and gave a talk on the human development. Was it the human development? What were you talking about? It was a great talk.
Which one?
I don't know, you gave lots of them, they were really good. Yeah. And I said, this guy's really good. I wonder if he has an advisor. He didn't yet, and so I fooled him into becoming my student, so I was thankful for that. Okay, Simone, great to have you here. All right, so population subgroups. Consider the following example. Don't you love it? Here's an example. Person 1, person 2, person 3, person 4. These are cutoffs. Now it's income expressed in some unit, who knows. Years of education, years of schooling actually. Sanitation, improved or not. Is it improved sanitation or not? Now that's really a categorical sort of a thing because you probably have within one a whole lot of different types of sanitation. Okay. Access to electricity, one or not. Okay? So that's the example, and we have deprivation cutoffs of 500, 12, 1, 1. That should be easy for you to comprehend now, having done that original example. So we have, I think, red here. Is this in red? I never use red because it doesn't really work that well with me, although I can see it. I see cardinals flying around, but I can't really tell the males from the females that well. The males are red. Females aren't. Okay, sorry. So this is deprived, 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 right? So the deprivation matrix encapsulates that. Here it is. And let's suppose we have weights. I'm not going to explain that too much, but we have a lot of weight here. This is someone like Jean Drez, you know. Education. Schooling is important. Actually, he would go further and say quality of schooling is much more important. Okay, but you can tell what the relative weights are for each of these. They still sum to 4. Does all this make sense? All right. So let's suppose that K is 1.5. Who's poor? Okay, I got to add up those babies, don't I? Yeah. Let's see. 1.5, person 2. What do you think? Oh, remember, it's that level or above. Sorry, guys, I forgot to emphasize that, but that's part of what this example is doing. You could have it so it's that level, that total value of deprivations added up, right? And greater, or it could be strictly greater than that. And there are measures that do it strictly greater, but we have taken the approach of having that be the cutoff that we say, if you're at that level, you are deprived, and beyond that, sorry, you are poor, and beyond that, you are poor too. Okay, forgive us because it is arbitrary and you can do it either way. But this person is considered to be poor by that definition. How about this person? Oh boy. Yeah, okay, so those 3, the same 3, and we don't have any censoring necessary here. Okay, so this is the weighted censored matrix, deprivation matrix. Too many words. What is M0 for this example? I don't know. Someone quickly add it up and divide by the number of entries. Actually, in this case, it is the same as dividing by the number of entries because the number of entries would be the same as if you add it this way and then add it up that way. You get 16. You have to. Okay, so I would think it's like around 15 over 32, but I could be wrong. Someone double check that for me as we move on. Okay, great, thank you. Okay, so that is M0 for this data matrix, for the one we had before. So now let's divide up, and you would divide the matrix of data up, but we can also divide up the various deprivation matrices. Okay, so that's what we're going to do. There's the pink group and the green group. All right? What is M0 for the pink group? Well, I'm going to be quick. Add it up, divide. We have 1.5 divided by 8. That's simple, and I'm standing in front of all you guys. Sorry about that. Okay? And how about here? Add them up, divide by 8. 6 out of 8. Pretty quick. Overall M0. Yeah, so average these two together, what do you get? This is 3 out of 16. This is 12 out of 16. Yeah, what did we get before? I forgot. Thank you. 15,032. Does it work? Are you sure? I'm not, because it's hard for me to do it staring at it from the side. And plus, I need more coffee. Okay, so the overall M0 was indeed a half times the A, so the incidence times the intensity, H times A, which is, oh, wait a minute, let me think here. H times A for the first one, H times A for the second one. Yes, it turns out it's the same thing. Okay, so the contribution of a group is what? You have the formula for before. So let's see. Contribution of group 1. So, oh man. Half times, I'm all mixed up. Can someone explain this to me? Yes, please.
Is M0 for the group 1
Yep.
and divided by the total M0.
Okay, and this is,
Oh, this is the A. A for the group.
oh, so, yeah, I'm
This should be in the bracket.
oh, the first two terms should be in a bracket? Okay, that's fine, because when you multiply things, it's okay. You can put them with, you know, with division. Okay, so what's this first term again? Okay, headcount ratio, this is, oh, very good, okay. Great, that's 1/5, great. And the contribution of group 2, what's this again?
Population ratio.
Now I'm all mixed up.
It all should be actually 2 divided by 4 because this is the population and then there is 4%.
Oh, so maybe this is the,
It's just simplified.
this is the population.
Yes, population ratio. 2
Oh,
divided by
okay, that's better. So, yeah, it's 1 out of 2 because half the population is in the first group. Great, put that baby up there. Let's go back to the formula just to remember what we're doing here, because it's just terrible for me to remember. Oh, here it is. So you have this, which we can put out in front and easily calculate, and then this was just as the ratio of the two. Okay, that's easy. Now let's go back and see what it says. Okay, so this is half, yes indeed. This was the M0 for group 1, M0 overall. Notice the same one, but it's not group 2 here, and therefore the calculation works out beautifully. You should be able to do this yourself now, right? Okay, just N1 over N, first thing, and then the two ratios of the level multidimensional poverty. Okay. What about the total? Does it sum to 1? Yay, it's probably right then. Okay. Great, so now let's go to dimensional breakdown. Dr. Dimensional. Yes, please.
Isn't contribution a little bit misleading?
Why?
I think it's more like what share of 4 people are in region 1. That's what we
Fair enough.
So with contribution is, I don't know, for people who do micro decompositions, it's more about changes in the middle, conflicts on some other.
I'm happy to look at your definition of contribution. What would it be? This one says, yeah, like I said over here before, we're really looking at in contribution the share of poor people overall that come from group 1. So it's its contribution to overall poverty. Sort of makes sense.
Yeah, it's semantic.
Yeah, and one could look at other contributions to overall poverty. You could. I mean, there are other ways of thinking about it. You could look at marginal contributions. This is sort of average. Right? I mean, who knows? So there are different definitions. But this is the way that we're doing contribution. Why? Because frankly, this is the way I did it in the 84 paper. To see how, you had contributions to overall poverty arising from subgroups. I just use the same formula. It makes intuitive sense, mostly, and if you have another one that needs to be defined, I'm happy. Okay, so a second form of breakdown for M0. The first one was a kind of breakdown too. This is called dimensional breakdown, by the way, because there's a little bit of a difference here that you have to first figure out who is poor before you do anything in this world. So it isn't able to sort of decentralize calculations according to each dimension separate from one another, because you need to know whether a person's poor before you can proceed, and to do that you have to know other dimensions. But once you've found out who is poor, it's as if it's a decomposition. So we call it a dimensional breakdown to distinguish between those two cases. Subtle point, don't worry too much about it. So we're going to do it by dimension instead of population subgroup. This will help identify deprivations that are mostly experienced by the poor and those that are not very often experienced by the poor. And over time, or even over experiments, it can help gauge the progress in reducing deprivations and hence poverty. Got it? Okay. Before I get on to anything more, I want to give you a definition. 2 definitions, in fact. These are important definitions, so remember them. One of them is called the uncensored headcount ratio of a dimension. Okay, and this is what the Millennium Development Goal is giving us when we say the percentage of people, right, who are suffering from this problem. That's the headcount ratio. Uncensored headcount ratio of that dimension is that. It denotes the proportion of the population deprived in that particular dimension. Okay, so I could look in the group and see your deprivation marker above your head like a little, in a cartoon. Right? And then I could see the percentage of ones for people who are deprived, over the total number of people. And that would be what you're calculating here. By the way, whenever you're doing this sort of stuff, you can calculate it from the weighted deprivation matrix. But it's easier to calculate it from the unweighted one, because everything then is ones and zeros as opposed to weights. You gotta kind of overlook the weights, because weights are only when you go across dimensions, not within a dimension. See what I'm saying? So if you're trying to figure out the uncensored headcount ratio, as we'll see in a second, I'll show you just add up the ones in the column of the unweighted deprivation matrix. Same thing for censored headcount, except for the censored headcount ratio, we have to go one step further than you do with the uncensored. You go through all the discussion to calculate M0. Construct the weighted, right? Construct this weighted censored. And at that point you say, we've got the censored deprivation matrix that's weighted. Let me go back to the censored unweighted deprivation matrix. That's the easiest way to calculate things, because you're going to once again find out the number of ones in the column. But the ones mean something different in the censored matrix. The one means, if you're looking at it, one means that you are both poor and deprived in that dimension. Because all the people who aren't poor are gone. You've censored them out. So, to measure this, which is the proportion of the population that's both multidimensionally poor and deprived in that dimension at the same time, you can go back to the unweighted censored matrix. Yes?
One question. So, between the both measures,
Uh-huh.
you only changes the denominators. For the first one is end, and for the second one, if you are using your...
We're using n still.
You're using
We're
end.
using n still. So it's the percentage or proportion of the population, the overall population, n itself.
But it says of the population that is multidimensionally poor.
Right, that is both multidimensionally poor and deprived in that dimension.
Yes, but what I mean is if you have 100 people in the population.
You have 100 people in the population.
Yes, but...
And you have all these people deprived in dimension 1.
Yes.
All of them. But only these people who are deprived and poor. These people as a share of the whole group.
Okay.
That's it. I could look at these people as a share of the whole, but that would be the first one. And so you guys are the troublemakers. Okay, you're the ones that are not poor but yet deprived. So if you use a dashboard approach, the raw dashboard or the uncensored dashboard, you're going to be included
Okay.
even though you're not poor. Interesting, isn't it? So maybe if you're focusing on extreme poverty, you may want to focus not on your guys, but you guys only. If I'm in the Ministry of Health, I want to focus on everyone if it's health in which people are deprived. But if I'm in the Ministry of Social Development, then I'd like to be focused on you. Other questions? Yes?
So technically it would be possible that the uncensored headcount is higher than the censored headcount.
Yes, it
right?
can be very much
Would
so.
this
We've
be
just done
like-
it with that example.
And the suggestion that this dimension or this indicator is maybe not what we want to use for this measure, because it's not really characterizing what the poor look like, or
Yeah. Yeah, but this is what's used very often. This is what people claim to use in dashboards. It's what's in the MDGs, which is fine because they're doing something slightly different in the MDGs. But if MDGs were a poverty exercise entirely, then you would probably want to look and focus on people who are multiply deprived first. At least I would think so. But others may not. So it's a very interesting debate, and you can see the debate between Sabina and myself and Martin in the blogosphere. This kind of discussion is there. And we'll have that debate just slightly discussed in this report that we've been working on. Okay. I wanted to give you this definition first because I think it's important to make the distinction between these two and understand how they differ. All right. Now, this is the really important subject matter definition for the dimensional breakdown. Okay, so let's take an example. Here's an example again. Oh, yeah, that looks good, doesn't it? All right, look familiar? Let's replace entries, 1 if deprived, 0 if not deprived, got it. What's the uncensored head count ratio for each of the 4 dimensions? So here's, I haven't done any censoring at all. Here, what is it? 1/2? 1/2, yes. How about here? 1/2? 1/4? 1/2? Yeah, that's right. I think you're right? Okay, great. So that's pretty straightforward. In this case, by the way, depending on how you define who's poor, it may be the same. Okay, suppose the weight vector, however, is 1, 2, 0.5, 0.5. Well, who knows? Maybe it's going to be different because the weights, right? No, weights don't matter except to determine who's poor. So let's see who's poor or not. And then that'll be the issue that matters. Okay, so we replace the deprivation status with weights. Here they are. Right, I know that. Construct the deprivation score vector. We have it. Is all this making sense? You've done it before. It's straightforward. And now you have to state a cutoff. So here's the cutoff. We're using 2 now, not 1.5. With 2, not 4. Okay, so there will be a difference for this example. Clever, Suman. Thank you. I would bet that Suman put together this particular example. Maybe wrong. Maybe it's Polly. All right, so you know who's poor. All these people are deprived, but only these 2 are poor by this definition. 2 is the cutoff. If you're equal to 2, you're fine. If you're above, you're also fine in terms of being identified as being poor. You're not very fine in terms of your well-being, but you're doing fine in terms of identifying who's poor. So 4 and 2, those people are poor. Let's now censor the deprivation matrix. Bingo. Aha. So there's M0. 6 out of 16. Add them up, divide by 16, you got it. All simple? All straightforward? Great. So, before we go one step further, I think I'll just ask you if you can calculate right now what the censored head count ratios would be in each dimension. Ignore the numbers. Imagine they're 1s, all of them. Exactly. So you've got it. That's the distinction. One of those deprivations over here was not relevant, so it disappears. Another one, not relevant, it disappears. as far as poverty is concerned in order to go from the uncensored to the censored headcount ratio. Okay, so here's M0 equals 616, great. Dimensional breakdown, dimensional composition, you can go both ways. Okay? 4 dimensions denoted D equals 0. Yes, that's what we have. And here are the silos. But the silos are constructed after we've already figured out who's poor and thrown out the deprivations that are not poor deprivations. Okay? Before, if you siloed it the way we did with the uncensored, you're including everyone, including non-poor deprivations. All right. So what is the censored headcount ratio? You've just calculated it and you were right. Right? All right. So this is straightforward. Now what do we do with it? M0 and the censored headcount ratio. Can I just ask you to think about this? You know, you're cutting this way first, ignoring the weights or the values of each deprivation for a moment, and then determining this share. If you reapply the weights as a share of 4 or D, so if you reapply the percentage weights for each dimension, what was this one? This is 1 out of 4. So 1/4 times the censored headcount ratio, 2/4 times this censored headcount ratio, 0.5 force times this censored headcount ratio, and 0.5 force times censored headcount ratio. Think about it for a moment. It turns out you're just reconstructing M0 because you're putting these numbers back in essence. When you multiply that 1 by its 1, you get 1. Multiply the 1 by 2, you get 2. Oh, add them all up, you get M0, which automatically tells you that the weighted average of censored headcount ratios is going to be M0. That's kind of cool. Here's the formula. M0 of a particular X is equal to the summation over the subgroups, 1 and 2 is the way I like to think of it, of the percentage weight, right? Because the D, the way it happens is that you're dividing through by D in each case. Here is the weight, here is the headcount, censored headcount ratio. We get the overall M0 that way. The factor of D is a little off from what I said previously, but this is the right formula. Okay? So, isn't that interesting? This is a formula that links the censored headcount ratio, the kind of monitoring of how deprived in that dimension poor people tend to be. You see what I mean? Or overall, how much poor deprivation there is in that dimension is really what it's saying. And you're aggregating it up to get the overall M0 and linking to it. So M0 is coordinating all the different sub-dimensions. Cool. Okay. Yeah.
Why do you have D there? I mean, it could have been just normalized weight.
Yeah, it could be, but then you'd get, you do divide through by a D because you've already divided through by N. So remember the denominator of M0, it's N times D. You're really dividing through by when you take the matrix approach. Adding up all those entries and dividing by the number of entries overall, it's N times D. That's what's going on. Okay. Sorry I confused you a little bit about that. I was giving you the intuition and neglected the details. So we've got the formula. It looks similar to the population decomposition formula, kind of a weight now in terms of deprivations, times some indicator, which is over that particular dimension. And so we can calculate a kind of a contribution. Is it a contribution? Read the book. You'll see that there's some discussion as to whether it's a contribution or not, but at least it tells you the relative importance, if you will. And here you have it. Take the weight, divide through by M0, and that is the contribution. Entirely analogous to the subgroup contribution. Except now you have weight times the value for the subgroup, which is the dimension, over the overall value. Okay, so this is the contribution, and you can see how much of overall deprivation among the poor, right, how much of that is attributed to dimension J. That's what this gives you. All right. What's the relationship between M0 and the uncensored headcount ratio when a union approach is used for identifying the poor? Anyone who's deprived is poor. There's no one in this group, because everyone who's deprived at all is considered to be poor. So you guys join in and you become part of the poor group. Okay? You're welcome. So you see that in this case, when you use a union approach, the two approaches are identical. There's no difference between the censored and uncensored headcount ratio. Okay. Right. So therefore, with the union approach, you can take the uncensored headcount ratios and just weight them up. So you could take the dashboard like the MDG and just weight them up, not identify who's poor at all. Weight it up to get a coherent M0. Now you are doing some identification. Those who have any deprivation are poor, those who don't have any deprivation are not poor. But it's a pretty coarse prioritization. Okay, so what's the contribution of the education dimension to M0 in this case? Anyone want to help me with it?
Of education or for income?
Education or schooling.
And 4 divided 16.
Okay, so that's, could you tell me where 4 is coming from? Yeah. Oh, 4 divided by 6. Okay, so what's the,
Okay, following the formula.
oh, I'll go back because I'm going to forget this formula. Where is, oh, there it is.
Okay.
So I got to put this in first probably.
Okay,
Yeah.
Yes.
Okay,
So the weight for education is 2.
it is.
Yes. D is 4.
Got it, 2 out of 4. Great,
Yes.
that's up in front, 1/2.
Yes. And then the headcount for the dimension is 2 divided 4.
Yeah,
And then you multiply.
and you divide by
Yeah, and
the M0. And what is,
M0 was 6 divided 16.
oh, you were right, yes, indeed. So we've gone through this application very nicely. 2 out of 4, 2 out of 4, 16. If you multiply and divide, you get 2/3. Isn't that nice? Yes, you need to calculate that. You should be able to do this without thinking. That's the idea. This is weights. Okay. Everyone gets it? Okay. What?
Because when you add up the weights here,
Yeah.
the addition is coming out as 4.
Huh?
Because 1, 2, 0.5, 0.5.
Huh?
And this is also the number of dimensions.
Uh-huh.
Is it a coincidence?
No, we do that on purpose. We could have made it so that the weights add up to 1, or we could make it so the weights add up to D and then divide by D later. Both ways are the same.
But suppose I would weight it like 1, 2, 3 and 4. Suppose
You could
these are
do,
my
but then you'd get some strange number and you'd have to divide by that number.
Yes.
In which point I would say, why don't you just divide by 4 and scale down those numbers?
Well, I mean, in practice, generally, my weights may not add up to 4. I mean, my weights can be
Yeah.
like, I can have.
But everything is 100% homogeneous in that. So it doesn't matter. You want to multiply it up, great, just so long as you divide by the same thing, the total. And then it's going to be my weights also, and everyone's weights. Whether I started out with 0, 1, adding up to 1 weights or not, it'd be the same. So we give the 2 approaches in the book, which are add up to the number of dimensions or indicators. Secondly, add up to 1. You could add a third one, add up to any damn thing you want, and it would still work and give you the same M0, no problem. So I agree with you. This is a good exercise to think through these things. Yes, go ahead.
And you will find an appendix at the end of chapter 5 where you have different formula using these different weights that sum to 1 or sum to the number of dimensions. So you have different formulas
Yeah.
available there.
So it's all there and all fastidiously done so that you can make sure you're on the right track and are not making an error in it, because it's easy to make an error when you have different approaches for the same thing. Okay? All right, so here's your final exam about this. What's the difference between the uncensored and censored headcount ratio? You can tell me, right? Yell it out, all of you at once. The censored head count ratio is wow, that was anemic.
Multidimensional
Actually, consider the deprivation
Yeah.
of people who are only poor.
Okay, so censored is poor, deprived, and at the same time, the percentage of the whole population that satisfies that condition. Yep. And what about uncensored?
only the time.
Deprived and jet. That's it. Great. Can the uncensored head count ratio be lower than its censored? Lower. So you're going to become negative people? No, you can't become negative people. The only thing, the worst is worse, you could all be the same. So that's it. Because one is strictly a subset of the other. The people who are poor and deprived in that J are a subset of the people who are deprived. So it has to be one way, not the other. Can the censored head count ratio dimension be higher than multidimensional head count ratio?
Can
Higher. Yeah, multidimensional head count ratio. I don't know the answer to this. How about M0? Can it be higher than M0?
It can be.
Of course,
It can be.
because you average up, and some of them could be really high, you average with low ones, and you get the M0. That's fine. Now let's think about the head count ratio, which is H times A. A is less than 1 typically. So it can be. It's bigger than H times A, it's bigger than H. It can be bigger than A. What? You disagree?
Yeah, because censored count ratio, those people, they have to be poor and deprived. So how can that be bigger?
No, but it is.
No. I said, can the censored head count ratio of a dimension be higher? So, yeah, tell me once again, what's your problem?
Because when you compute censored count ratio, then these people have to be multidimensionally poor already and deprived.
Uh-huh.
So how can there be somebody who is not multidimensionally poor but deprived?
Oh.
I think that this is just
Oh.
saying that whether one value can be more than the other.
Oh.
It's your thing, it's not my thing.
No, I've been corrected. Oh my gosh, it happened finally. Do you see what he's saying? Okay, so you have a maximum, right, of every censored head count ratio. Isn't that maximum? It's the intersection of two things, so take the one set, all who are poor, that percentage of the population is bigger than the head count, the censored head count ratio, because the censored head count ratio adds to that another condition of being deprived in that particular dimension. So if everyone were deprived in that dimension who was poor, the maximum that you could have would be the head count ratio, overall head count ratio for the censored head count ratio. If that dimension, everyone in that dimension was deprived, everyone in that dimension was deprived. The whole room is deprived. But these are the poor folks. Who would be the ones that are deprived in that dimension and poor? Okay, so thank you, Suman, for correcting me.
But aren't you talking about two different denominators in those? Like the censored head count ratio is over poor people.
No, it's not. And that's a common mistake. It was made over here a little bit ago, and now, okay. So it's the percentage of the overall population that is deprived and poor. Okay, so thank you for answering that correctly. And if I make another mistake, correct me again. What's the relationship between the censored head count ratios and M0? We know that. We just looked at the formula, the averaging. And then finally, what kind of policy analysis can be conducted using the censored head count ratio? Well, is someone else going to talk about that, Suma?
Sorry?
Is someone else going to talk about policy?
Yeah,
I think so.
Come back afterwards.
Yeah. But all I can say, yes, go ahead.
Question number 3 again.
Uno, dos, tres.
I mean, my question is, what is the maximum value of head count ratio of a dimension? Censored head count ratio of a dimension.
One maximum is the overall H of the multidimensional H.
If the censored head count ratio of a dimension can go up to 1,
It can if H is 1.
so then I think the value then it is averaged across dimension because all the dimensions were taken.
Exactly what I thought,
Yeah, so that's how then in
but
this-
not right. Because if the overall headcount ratio is 1, okay? Or what did you say? If the censored headcount ratio is 1?
Yeah.
Okay, so the censored headcount ratio is 1. What percentage of the people are poor? It's got to be everybody because everyone's poor and deprived. So they're equal. They're both equal to 1. HJ and H are the same. That's the idea that was, thank you. Okay. Other questions? No. Then let's continue. All right. Properties. Now, M0 is part of a methodology which includes who is poor. Who is poor gives you a dual cutoff approach that says you first cut each deprivation, right? You cut off to see who is deprived or not, and then you have another cutoff across the breadth of deprivations to determine who is considered to be poor. Who is poor is identification. That's the first part of the methodology. How much poverty there is, as measured by M0, is the second part of the methodology. Both of them are needed in order to succeed in what we're doing. Much of the discussion previously in multidimensional did not consider practical ways of identifying who's poor. They had ways that depended on the cardinal structure, and there were ways that you just never were given an example in any of the papers because they're arbitrary. A frontier, like a production possibility frontier. Right. Tell me how you got that frontier and how to make sense of who's poor. So these properties in the context of multidimensional all concern both parts of the methodology. Symmetry, you probably know that if I take you and switch who you are, in other words, I give you her and her, then it means that poverty should be unchanged. That's the case that we don't put weights on people. That's what symmetry is all about. Scale invariance. Suppose that we took, and doubled all the matrix entries. Okay? And we doubled all the cutoffs. All right? What should happen to poverty? Well, with the FGT indices, we know what happens, and the same thing happens here. You don't change overall M0. By scaling everything up, you still have the same people who are poor, because you scale both up. More than that, the number is scaled up and divided also by the same scale. So the same number is there. Normalization talks about what happens if you have absolutely no one deprived. 0 poverty, clearly. And it also can talk about the other extreme, which is that at maximum it's 1. It depends on which normalization we're talking about. Replication invariance says that if I take a group of people here and clone each one of you and put them over here, you're the clones, then the level of poverty here is the same as the level of poverty overall plus clones. We're measuring poverty per capita wise, not in an absolute sense of total amount of deprivation and poverty that people have. It's as a share of the population. That's needed, otherwise you'd have China ruling the day every day, and India not far behind, and that isn't the case. Ordinality, we talked about, that if you measure things differently, according to a rescaling, that it shouldn't affect the M0, it shouldn't affect who is poor. And that's satisfied through our discussion we had. Poverty focus means that if someone's not poor, and you, let's say, lower their, increase a level of attainment in the X matrix, it should have no impact on what's going on. Lower it, well, it could, because you might then hit a deprivation, but increase it isn't going to affect anything. Deprivation focus means that if you increase or decrease someone's attainment when it's above the deprivation level, it ain't going to affect the final number. That's deprivation focus. Weak monotonicity, that if you take anyone's achievements in X and increase them, or one of them, just increase it somewhat, it should never increase poverty. Okay, poverty either falls or stays the same. That's weak monotonicity. Weak deprivation rearrangement. Suman, explain that. Did you write a paper on this?
Yeah.
Something very close to it, right? So why am I interested in weak deprivation rearrangement?
So we discussed yesterday about some sort of transfer, right, on inequality. So when you have the single dimension, you understood the transfer, right? Taking income from the richer poor to giving the poor
Mhm.
does the change about it. And when you move to a multidimensional context, okay, you have more than one dimensions. And yesterday we were talking about, or this morning as we were talking about association between dimensions, right? You saw that example, you had two distributions where one person was poor in all indicators, whereas in the other achievement you had only one person has one deprivation.
Mm-hmm.
So in that society you had same sort of deprivation counts in that sense. However, the second matrix, the association between dimensions were much higher than the other matrix. So the idea is that you can obtain the way we were obtaining one vector from the other. Here you can actually obtain this right side matrix where one person was deprived in everything from the left side matrix by changing the association. The main difference between the two is that deprivations, they are more associated in the second society where one person had all deprivations than the first society. That means one matrix is obtained, the right hand side is obtained from the left hand side by increasing the association or correlation between dimensions.
So let's do that right now. Can I do that for these fine people here?
Yeah.
4 people? You have one, you have one, you have one, you have one. You're the unlucky person. So what we're going to do is in the first dimension, where you already have one, no one else has anything, fine. Second dimension, you have a deprivation, you don't. Switch. Rearrange. You just got more deprivations, and you got less deprivations. That means you got more achievements and less you have. So that's a rearrangement we're talking about. It's a association increasing rearrangement, if you will. And now let's do the same here. You're in 3, you have a deprivation. Guess what? Here's this poor guy. Switch. Now you have 3 also. You have 0 and you're happy and you go home. 4, switch. So we keep bringing up the association for this person and for the rest of you, because you all have 0, and associated is very, it's all very nice because everything is 0 and you have everything is 1. That's kind of an extreme case of a series of weak rearrangements, that they're not weak, they're actually strong, they're flipping things back and forth. The question is, as a result of this, which leaves you ghettoized, in essence, you're deprived in everything. What should happen to poverty? And the answer most people would agree is that it should not decrease poverty. I mean, you might say it does increase poverty, and I think intuitively it does. But at the very least, it should not decrease poverty, and that's the weak deprivation rearrangement. By the way, it's kind of tough to create one that's not weak, but in a paper we're working on, we're doing that. Yes, question?
When you say it should not decrease poverty, suppose I consider my poverty measure to be such that if you are deprived in one of the dimensions you are poor, then it has decreased poverty, because earlier it was 4 people are poor because in one dimension they are poor. This is the second condition where all 3 of them are non-poor and 1 is poor. So that makes it 1 by 4.
So it always has to be between poor people, right? So that's the thing. But you're right. I mean, that there are a ton of exceptions that you can think of in practical reasons that might get you to say, well, I'm not sure it holds in all cases. But this is what many people would agree with. They think this is really the approach that makes sense. I'm always a bit unsure about it myself, but I'm happy to discuss it with you, because it could be that the 2 are complements, or maybe they're substitutes, and it would have a totally different impact in both cases. So this is making a particular assumption about the relationship between the dimensions. But that's fine. It's a reasonable assumption. Dimensional monotonicity, decomposability, dimensional breakdown, all those are satisfied by the technology we have described, and I think that I am through, and it's your turn. Sabina.
No, I don't have anything to add. You're 10 minutes to discuss with you.
Oh, okay. So, should I just stop here, leave this slide open for you to begin with,
No,
or?
I'm not gonna do any more. You taught my bits too.
I did?
Yeah.
I'm gonna ask for twice, sorry?
You could have been resting and having coffee.
I'm gonna ask for twice pay, okay? And I am positive I will get it. Of course, everyone knows what 2 times 0 is.